So this should be the second video that you're watching on x-intercepts, y-intercepts, and zero review. One thing to point out, remember that zeros is just a fancy word for x-intercept. If you see zeros, think x-intercept, they're just trying to fool you, okay? So to find our x-intercept, we're going to need a point. We take our line on our graph and we follow it up till it crosses the x-axis. Where those two intersect and meet, that's our x-intercept. To get to that point, our coordinate is over 1, 2, up 0. So we write our coordinate point as 2, 0. Okay. For our y-intercept, we do the same thing, but we look for where our graph crosses the y-axis, the up and down or vertical axis. Crosses right here, and we can see that that's 1, 2 below 0. Our y-intercept is over 0 and down 2. Okay, let's do one more. All right, looking at the y-intercept and the x-intercept for the second one. All right, if we were finding our x-intercept first, we follow our graph down until it meets our x-axis. This might be a little off, but I'm going to say that's close enough. And it looks like this intercept is actually in the same location. It's over 2 and up 0. Our y-intercept, if I follow it down till it crosses the y-axis, is at positive 2, so over 0 and up 2. You'll notice that x-intercepts have a number for x and a 0 for y. Y-intercepts have a 0 for x and a number for y. Okay, so there's a 0 for whichever one we're not measuring. Y-intercept has a 0 for x, x-intercept has a 0 for y. Okay, moving down to the bottom, if you're trying to find the y-intercept from an equation, you're going to cross off or plug in a 0 for the one that you don't need at the moment. Remember that an x-intercept always has a 0 for one of them, right? It's going to be a 0, an x value, and a 0 for y, right? An y-intercept is the exact opposite. It has a 0 for x and a y value, okay? So let's set up our equation. We have 2x minus 4y equals 8. I know that to find my x-intercept, I need a 0 for y. If I put a 0 for y, it's going to go away. That means I can cross it off. This, with a 0 in it, goes away. So, to solve for x now, I just need to divide by 2 on both sides. That cancels out, and I get that x is equal to 4. So my x-intercept, when I put a 0 in for y, is 4, 0. I follow the same process again to find my y-intercept. 2x minus 4y is equal to 8. But this time, to find the y-intercept, I'm putting in a 0 for x. That means when I put a 0 in for this, it goes away. I can cross it out. Remember that negative is with the 4, it needs to stay. So to solve for y, I divide by negative 4 on both sides. That cancels out, and I get y is equal to negative 2. So my y-intercept is 0, negative 2. Okay? So I'd like you to do the even numbers on the front, 4 and 6, please. And then on the back, you can, when it says find the 0, remember this just means x-intercept. Even says so at the top of the paper, okay? You can solve this algebraically using the 0 method that we just did, or you can graph it in Desmos and find the x and y-intercepts from a graph. Either way, remember to graph it in Desmos. You just need to type it in, look at the graph, and find the intercepts, similarly to how we did on the front of the page, okay? I'll solve one more for you so that you have one more example. Remember, if I want to find the x-intercept, an x-intercept has a x for a number value and a 0 for y. So if I want to find the x-intercept, means I'm putting a 0 in for this y. I can cross this term out. Okay? That means I just need to solve 3x equals 18. To do that, I need to divide by 3 on both sides, cancel that out, and I get x is equal to 6. So my x-intercept, this is not my answer. My answer is my point. My x-intercept is 6, 0. Similarly, to find a y-intercept, remember that I need to have a 0 for x, and I'm finding my y. So if this is 0, the x is 0, it would cancel this term out. And happily enough, this is already solved for us. Y equals negative 16. Ta-da! That one's already done. Nice. So when x is 0, we get a y-intercept of 0, negative 16. Okay? Remember, you're solving 2, 4, 6, and 8, and you can use Desmos or the algebraic method that I've shown you here.